Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we are talking about NCERT class 11th today, and the chapter that we'll deal with is Trigonometric functions, which is chapter 3, and today is the turn of exercise 3.1. So without wasting any further time, we'll continue with the first question here. Let's take a look at this question. What does the question say? Find the radian measures corresponding to the following degree measures. Okay, you're given some angle in degrees and you have to find an equivalent angle in terms of radians. Radians, that is the SI unit of angle. So how do we interconvert between these two things? We'll use something called interconversion formula. Now what are interconversion formula? Let's take a look at that over here. For interconversion, remember that if this is a straight line, right? And if we go about one complete rotation about this line, if we follow one complete rotation about this line, what we have is a circular path, right? A complete circle is equal to how many degrees or is equal to how many radians. That's the important thing. If you are aware of that, then we can apply interconversion very easily. For example, a complete rotation in terms of degrees is 360 degree. Degree is represented in this manner, right? In this fashion. This is 360 degree. What happens in case of radians? In case of radians, this complete rotation is equal to 2 pi. And in case of radians, either we can write rad over here or we can leave it as it is. 360 degree is equal to 2 pi radians. That's how it is read. Right. Once you are aware of this, we can find the conversion factor very easily. We can find the conversion factor. Yes, 1 degree. If 360 degree is equal to 2 pi, then 1 degree is equal to 2 pi over 360. What is that? Pi over 180 radians. Right? This is what you can have. This will be 1 degree will be equal to pi upon 180 radians. That's what you can observe clearly. Alternatively, you could also have found 1 radian. 1 radian will be equal to 360 over 2 pi degree. That's what you can have. 2 pi divided over here. 1 radian would be equal to 360 upon 2 pi. This is very simple ratio and proportion concept. And what are we doing over here? That if you get in 360 rupees, if you get some number of toffees, then in 1 rupee, how many toffees would you get? That's the simple idea behind this. In 360 rupees, if you get, let's say, some 1000 toffees. So in 1 rupee, you will get 1000 upon 360 toffees. Here, instead of 1000, we have a 2 pi, right? Imagine in that way, right? So once you have imagined in that way, similarly, we have found 1 radian is equal to this. This is a conversion factor. Okay, and what are we trying to solve over here? We are trying to solve degrees in terms of radians, right? We are trying to write degrees in terms of radians. Let's begin with the first part over here. The first part has 25 degrees. Now 25 degree, 1 degree is equal to what? This is basically 25 times 1 degree, yeah. So this is 25 times, imagine this as this is 25 times 1 degree, right? This is 25 times 1 degree. And what is this equal to? 25 is okay. 1 degree is equal to something. We found that 1 degree is equal to pi over 180, and this is in terms of radian, right? So this is 25 times pi upon 180 radians. This is what you get, right? And remember one more thing. For if you have any kind of confusion related to do whether we'll be multiplying with pi by 180 or whether we'll be multiplying with 180 upon pi, remember that the measure in radians, mind you, the measure in radians, the value in radians would be much smaller as compared to the value in degrees, numerical value. Like 360 degree was equal to 2 pi. Now 360 degree is huge number as compared to 2 pi, right? 180 degree is equal to pi radians. Pi is approximately 3.14. 180 is a huge number. So in terms of degrees, you get a numerical value which is much bigger. In case of degrees, you get a numerical value which is much bigger. So this numerical value has to be bigger as compared to the value in terms of radians. This is what you'll be doing, right? Pi upon 180. If you multiply this factor over here, you'll get the value in terms of radians. Okay? So let's simplify this further. 25, 180. Will this get cancelled? Yeah. The factor of 5 will get cancelled, and you can say this is 5 pi over, what you get over here is 36 radians. This is what you get, right? Or you can simply write it as 5 pi over 36. There's no need to write RAD over here. This 25 degree is equal to 5 pi upon 36 radians, right? This is what you find. This is first part for us, which is very simple. Similarly, we can find the remaining parts as well. Let's try to do that. Let's try to solve for the second part. What does the second part say? We have minus 47 degree 30 minutes. Now that 30 minutes has to be converted into degree first, right? So what you have is minus 47 degree 30 minutes. Now 30 minutes is basically half a degree. 1 degree, since 1 degree has 60 minutes, 30 minutes would be half degree. This is minus 47.5 degree. This is what I have, right? Minus 47.5 degree, right? That's pretty simple, yes. Since you are aware of the degree angle, now you can find the angle in radians. Simply multiply by pi by 180 and you get the angle in terms of radians. Minus 47.5 times pi upon 180. What else? Is there anything else? Yes, you can simplify that factor. This factor. This is 47.5 can be written as 95. You can write it as minus 95 over 2 times pi upon 180. I'm writing 47.5 as 95 upon 2 so that I can cancel the factors. Let's do it. What you have over here is 5. A factor of 5 gets cancelled. This is 19. This is 36. So what you get is minus 19 pi over 72. Minus 47 degree 30 minutes is equal to minus 19 pi upon 72 radians, and that is my answer over here. That's okay? Yes, that's pretty simple. What next? Let's talk about the third part after this. For solving the third part, let's get rid of this thing over here, and what do we have remaining is, let's take a look at this third part. 240 degree. Now what is that equal to? Let's take a look at this 240 degree. 240 degree will be equal to 240 times pi over 180 in terms of radians. This is in terms of radians, right? 240 times pi upon 180 radians. Now what is this equal to? This is basically 60 times 3 and 60 times 4. This is 4 pi by 3 radians. 240 degree is simply 4 pi by 3 radians, right? That's clear? Yes, that's pretty simple. What next? Fourth part. In the fourth part, you are asked to find 520 degrees. 520 degree is equal to what? 520 times pi by 180 radians, right? This is what you'll get. And what is this further equal to? We can cancel a factor of, can we cancel anything? Yes, a factor of 2 at max, that's all. This is 26 pi upon 9 radians. This is 26 pi upon 9 radians. And with reference to this question, that is enough for us. But then, since we are talking about degree and radian interconversion, we should study one more thing. We should take a look at one more thing, that is some standard angles whose degree and radian, both values you should be aware of both versions, right? Let us talk about some standard angles. For example, 0 degree, 30 degree, 60 degree, 45 degree first, and you have 45 degree, 60 degree, 90 degree. Okay, these are very standard, right? After 90 degree, you can move on to next 120 degree, 135 degree, 150 degree, 180 degree. What else? After 180 degree, you can move on to 210 degree, 225 degree, 240 degree. We have just found 240 degree, right? That's a standard angle, yes. Many times you would encounter these angles, right? So you should be aware of their degree measures and their radian measures simultaneously. Next is 270 degree, 300 degree, 315 degree, 330 degree, and 360 degree, right? These are some measures. So what is 0 degree is equal to? 0 degree in terms of radian is simply 0. 30 degree is simply pi by 12. This is pi by 6, not pi by 12. 0 is 0, 30 degree is pi by 6, this is pi by 4, this is pi by 3, this is pi by 2, okay, right? What else? In case of this range over here, this is pi. You remember 180 degree, this is pi, this is 2 pi. You remember these angles, right? Pi and 2 pi are pretty simple, 180 degree and 360 degree, but the others can also be found. Now 45 degree times 3 is 135 degree, so this is actually 3 pi by 4. This is actually 3 pi by 4. How do we find 120 degree? 60 times 2 is this. So this is 2 pi by 3 actually. What about 150 degree? 150 degree can be found by multiplying this with 5. 30 degree times 5 is 150 degree. This is 5 pi by 6. Right? This is 5 pi by 6. Or you can also do one more thing. 180 degree minus 30 degree. 180 degree minus pi by 6, that is pi minus pi by 6. Pi minus pi by 6 is 5 pi by 6. Similarly, 210 degree is pi plus pi by 6, which is 7 pi by 6. Right? This is under the standard angle. Pi plus pi by 6, pi minus pi by 6. With the help of these. With the help of these. What about 225 degree? Can you imagine now? 225 degree would be based on this. 45 degree. 45 degree times what? 45 degree times 5 is 225 degree. This is 5 pi by 4. What about 240 degree? 240 degree is nothing but 120 times 2, which is 4 pi by 3. You may observe that, right? What next? 270 degree. 270 degree is simple. 270 degree is actually, if this is 90, 90 is pi by 2, this is 2 pi by 2, this is 3 pi by 2. Then 300 degree. 300 degree again, this is pi 30 degree and 300 degree would be 10 times this. 10 times pi by 6 would be 5 pi by 3. There's another way of reaching 300 degree. What is that? 360 minus 60. That is 2 pi minus pi by 3. 2 pi minus pi by 3 is 5 pi by 3. What about 315 degree? Yes, 315 degrees, 45, 135, 225 and 315 are similar. This is pi by 4, this is 3 pi by 4, this is 5 pi by 4, this is 7 pi by 4 over here. What about 330 degree? This is 2 pi minus pi by 6. 2 pi minus pi by 6 is 11 pi by 6. This is what you have. Right? This is 11 pi by 6. I hope these are clear, right? A few more angles remain, yes. What are a few more angles? Let me write a few more angles in terms of degrees and radians. 15 degree, 75 degree. These are some angles. 22.5 degree, which is also 22.5 degree. Now, what are these measures in terms of radians? 15 degree is equal to basically half of this. This is pi by 12 for us. What about this? This is 5 pi by 12 for us. What about 22.5 degree? This is half of pi by 4, which is pi by 8 for us, right? So remember these values. Yes, these values are important and you should remember these values very nicely. So can you observe that 180 degree is pi, we have pi by 2, pi by 3, pi by 4, and do we have pi by 5 as well? No, we haven't written pi by 5. Let me write pi by 5 as well. 36 degree. What is that? That's it. 36 degree is pi by 5. So is 36 degree also in standard angle? Yes. When you're preparing for competitive exams, you would also be required to remember the values of sine 36 degree, cos 36 degree, right? Sine 18 degree, cos 18 degree, and we actually tend to derive all of those values. How do we get those values and all, right? So 36 degree again standard. Then you have pi by 6 is you are aware of pi by 6 now. Pi by 7 now, 180 degree is not divisible by 7, but pi by 8 is something which you have dealt with. Pi by 9, you can deal with pi by 9 as well. Pi by 9 would be pi by 3 into 1 by 3, which is 20 degree actually. Then pi by 10 is something which you can deal with. Pi by 10 is 18 degree. Once again, a standard angle pi by 10. Okay, so these are some interconversions between radians and degrees. Okay, you have converted some angles in degrees into radians. After this, we'll take a look at the next question. So what does the next question say? Let's take a look at this. Find the degree measures corresponding to the following radian measures. Use pi equals 22 by 7. Okay, let's do it. We'll use pi equals 22 by 7. This is an approximation, yes. So let's talk about this part, first part. If this is 11 by 16 and we want to convert this in terms of degree, how do we convert that, right? If this is 11 by 16 radians, how do we convert it into degree? So for that we need to recall the interconversion formula. Okay, what does the interconversion formula say? That 360 degree, that is one complete rotation, is equal to 2 pi radians. Okay, so this implies that 1 radian is equal to what? 1 radian would be 360 upon 2 pi degree. What is that? This is 180 over pi degree. So basically, for converting from radian to degree, we'll have to multiply by 180 upon pi. And you can remember one more thing. What is that? If this is the measure in terms of radians, then the measure in terms of degree would be numerically bigger. So let's multiply with 180 upon pi. Don't get confused between multiplication with pi upon 180, right? You have to increase. In terms of radians, if this is the measure, then in terms of degrees, the measure would be bigger, right? So 11 by 16 radian would be equal to what? That will be equal to 11 by 16 times 1 radian. What is that? 180 over pi degree. That's what you have. And what does this convert into? Let's try to solve this further. And pi is given to be 22 upon 7. Let's use that value. So 11 by 16 times 180 times 22 times 7. 22 by 7 will, that 7 from the denominator will go over here. And this is the value in terms of degree that we want to find. Alright. Can we simplify this? Yes. This is 11 times 2, which is gone. This is again 90. Okay. And can we cancel this factor? Yes. This is 45 upon 8. So 45 into 7 is what I require. 45 over 8. This is 8. This is 45 over here. Okay. Let's try to simplify that further by first multiplying in the numerator and then dividing by 8 after that. So 45 times 7, 7, 5, 35, 5, 3, 28, 315 upon 8 is what we require, and this is the degree measure. What does this simplify into? What does this simplify into? Let's try to simplify that further by dividing this, right? Okay, so this gives me 11 by 16 radian is equal to what? 315, 8, 3 times 8 times 3 is 24, then you have 75, 9, okay, and then you have 72, this is 3 remains, 39 whole 3 by 8 degrees is what I get, right? 39 whole 3 by 8 degrees. Now 3 by 8 degree can be converted in terms of either a fraction or it can be converted in terms of minutes or seconds for that matter, right? 1 degree, as you may recall, 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. That's a further subdivision of a degree and subdivision of a minute, right? Okay, 39 whole 3 by 8 can be further divided as, right, 3 by 8 degree would be equal to what in terms of minutes? So 1 degree is equal to 60 minutes. 3 by 8 degree would be 3 by 8 times 60 minutes. So this is 39 degree 3 by 8 times 60 minute. This is what you will be getting, right? That's simple, yes. So this is 39 degree, which is okay. What is this further? Equal to 6, 318 is 180, 180 upon 8. This is 180 over 8 minutes. What does that equal to? This is further equal to 39 degrees, okay. This is basically, we can divide 180 by 4. And so this is 45 upon 2 minute. Let's simplify this further. This is 39 degree, 22 and a half minutes, okay. 22 and half would be 30 seconds, right? So this is 39 degree, 22 minutes, 30 seconds. That's the final measure of this 11 by 16 radian in terms of degrees and minutes and seconds. Obviously, those are the parts of this, right? That's all? Yes. What next? Next we'll solve the second part after this. What does the second part say? Second part says that we have to convert -4 in terms of, -4 radians in terms of degrees. Let's do that. So for second part, we have -4 radian. What is this equal to? -4 times 180 over pi degrees. This is equal to this. Okay. Now next we can write it as 180 is okay. This is 22 by 7 degrees, right? This is all going in terms of degrees. What does this simplify into? Let's try to simplify this further. This is 11, this is 2, okay. This is -360 times 7 by 11. -360 times 7 by 11, okay. In terms of degrees, we'll have to divide by 11, okay. That would be slightly difficult, but then we can always do that. Division by 11 would not be an issue, but we have to convert in terms of degrees, minutes and seconds. Let's do that. This is 7 times 6, 7 times 0 is gone, 7, 6, 42, 2, 4 carry, 73, 21, 2, 5, 2, 0. This is -2520 upon 11 degrees. What does that convert into? Let's try to find that. So this is -2, 2 times 22. Then you have 32, which is again 2 times this 22. Then you have 10, 100. 100 is actually 9 times 99. -229 degrees, and along with that you have 1 by 11 degree extra. 229 and 1 by 11 will be extra, right? 1 is the remainder, 1 by 11 degrees. That's one answer. That's one version of the answer. But then 1 by 11 has to be further converted in terms of minutes and seconds. Let's do that over here. 1 by 11 degree is equal to 1 by 11 times 60 minutes. Now what is that equal to? This is 11 times 5 is 55. 5 whole 5 by 11 minutes. This is 5 whole 5 by 11 minutes. Can you please note that? Yes. 5 whole 5 by 11. Further 5 by 11 minutes can be converted in terms of seconds. Right? Let's do that. This is 5 minutes 5 by 11 times 60 seconds. Now what is that equal to? 6 times 5 is 300. 300 by 11 seconds. This is 5 minutes times 300 by 11 seconds. Let's try to simplify that further. 300 upon 11. What is that equal to? 5 minutes is okay. In terms of seconds, is there any smaller unit than seconds? Yes, there are milliseconds and all, but then we are not going into those details. We'll solve up till seconds and all, right? So 11 times 2 is 22 and you have 80 after that. 80 will be 27. Okay. And 77, 3 remains, right? So 30 upon 11 would be again 2 something. So this will be 27 will repeat, I suppose. 27 it will repeat, and this is what you get. This is 27 seconds. On rounding off, this is what you'll get. So this finally becomes minus 229 degree 5 minutes 27 seconds. This is your answer for this minus 4 radian. That is finally converted in terms of degrees, right? This is the measure in terms of degrees. Right. Is that all? Yes, that is all for this part over here. So once you have done this, we can continue further and move on to the next part. That's the third part. What does the third part say? Third part, we already have a pi over here, 5 pi by 3. We already have a pi, and that pi will allow us to simplify the calculations, right? So 5 pi by 3. I hope you may recall that this is equal to something. We have just seen in the previous question the values of some standard angles in terms of degrees and radians. 5 pi by 3 and 7 pi by 6 are standard angles. If you can recall those values, let me know. 5 pi by 3. Now what is 5 pi by 3? This is 5 pi by 3 times 180 upon pi. And can we solve this? Yes, this is 300 degrees. Right? Pi and pi get cancelled. 3 times 6 is this, and 5 times 6 is 30. This is 300 degree. What about 7 pi by 6? Again, this is pi plus pi by 6. Pi by 6 is 30 degree, right? So pi plus pi by 6 would be 210 degree. That is something which we should be aware of. But let's try to calculate it from the basics. 7 pi by 6 would be equal to 7 pi by 6 times 180 upon pi degrees. Now what is that equal to? This is 6 times 3, which is 6 times 3, 30. This is 210 degree. That's my answer over here. This is my answer over here in this part. That's my answer over here in this part, right? So that is another standard angle, and if you want to practice, I would give you a few more angles, a few more standard angles, right? Just let us recall. In the first question, we had seen some standard angles. Let's try to recall a few radian measures, and you have to answer the corresponding degree measures for that matter. A few standard radian measures. Let us say if we have 3 pi by 2, what is this equal to? 3 pi by 2 in terms of degrees. Then think about the next one. The next one is 4 pi by 3. What is that equal to? Then you have a few simple ones also. A few simple ones, yes. Pi by 4 is equal to what? Pi by 6 is equal to what? Pi by 12 is equal to what? And 7 pi by 12 is equal to what? Those are a few more questions for you to solve. That what are the degree measures of these angles? Now can we find the degree measures of these angles easily? Yes. We recall that pi is 180 degree, okay? So 3 pi by 2 would be, actually this is pi by 2 times 3, which is 270 degree. We should remember this. 4 pi by 3 is pi plus pi by 3. Now pi by 3 is something which you should be aware of. Pi by 3 is 60 degree. Pi plus 60 degree, that is 180 plus 60 is 240 degree. Right? Pi by 4, 180 upon 4 is 45 degree. Pi by 6, 180 upon 6 is 30 degree. Pi by 12 is half of this, which is 15 degree. and 7 pi by 12 is 7 times 15 degree. 7 times 15 degree, what do you think would that be? 7 times 15 degree is 105 degree. 7 times this. This is what you get. And yes, those are some more standard angles for which we should be aware of, let's say, degree and radian both. Okay, the values in terms of degrees and radians both. This is all for this question over here. Let's solve this question next. What does the question say? A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Okay, a wheel makes 360 revolutions. Let's take a look at this. 360 revolutions in 1 minute. Now, one revolution, what would imply? In 1 minute, the wheel makes 360 revolutions. Okay, now one complete, if we have a wheel, let's say, one complete revolution would imply that this point over here has moved this complete path. Okay, so one revolution would imply that the wheel has rotated by an angle of 360 degree, or which you can measure it in radians. This is equal to 2 pi radians. The person is asking through how many radians does it turn in 1 second. Okay, so in 1 minute the wheel has made 360 revolutions. 360 revolutions is equal to 360 times 2 pi radians, and all of this is happening in 1 minute. 1 minute implies 60 seconds. In 60 seconds the wheel makes this much angle. So in 1 second, in 1 second, how many radians does it turn? It turns in 60 seconds. If it turns this much radian, then in 1 second it will turn 360 times 2 pi upon 60, right? We divide by that 60 radians. Now what is that equal to? This 60 times 6 to 12 pi radians. In 1 second, the wheel turns by, well, wheel rotates by 12 pi radians. That's what you can see over here. And yes, this is my answer for this question. It's very simple. The important thing is that 1 minute can be further converted in terms of seconds, and 360 revolution. What does one revolution mean? One complete revolution means that the wheel has rotated by an angle of 2 pi radians. Right? That is all for this question over here. Let's discuss this question in front of us. What does the question say? Find the degree measure of the angle subtended at the center of a circle of radius 100 centimeter by an arc of length 22 centimeter. Now, in terms of radius of the circle and length of the arc, you have some relation which relates both these things along with the angle subtended at center. How do we relate all these three things? Let's take a look at the idea behind that. If this is a circle, right, and let's call this the center, any point P on the circle can be this, and CP would be actually equal to the radius CP. This length CP would be the radius of the circle, right? Along the circle, if you traverse a distance L, along the circle, if you traverse a distance L, this is length of the arc. Okay, let's say you reach point Q and you join C with the point Q, right? So PQ, this arc PQ subtends some angle at the center. This is angle subtended at the center, right? Let's call this theta. Arc length is this along the curvature of the circle. This is the arc length, which is L. So L, R and theta are related by this relation L equals R theta. The important thing that L and R are lengths which can be measured in centimeters, meters, kilometers, whatever you want. But theta, that angle theta is important. Theta is in radians. Theta is measured in radians for this result, right? Once we find theta, we can convert it in terms of degrees. Or if we are given theta, then we can convert this in terms of radians as and when required, as and when asked, right? So for this given question, what is being asked and what is given is find the degree measure of the angle. Okay, the person is talking about degree measure. We're not supposed to give the radian measure. We're supposed to give the degree measure of the angle subtended at the center of a circle of radius 100 centimeter. Now radius is given to be, for this circle, the radius, okay, this is center, this is A, okay, this is R. R is given to be 100 centimeter, okay. What else? Of a circle of radius 100 centimeter by an arc of length 22 centimeter, okay. Arc is of length 22 centimeter. Let's call this L, arc AB. So L is given to be 22 centimeter, okay. So therefore, Find a degree measure of the angle subtended, right? This is required. Right? Theta is required. So if theta is required, what is the value of theta? Theta is L upon R, right? So theta is L upon R radian. What is that equal to? Mind you, it is in radians, right? L is 22, R is 100. This is 22 upon 100 radian. But are we required the value in terms of radians? No. The person has asked us to find the value in terms of degrees. So after this, the question becomes very simple. We have to simply convert this measure of radians in terms of degrees. How do we do that? We simply multiply by, in terms of degrees, if you have to convert this radian in terms of degree, we have to multiply by 180 upon pi. This is 22 over 100. This multiplied by 180 upon pi. Now what is pi? Pi is already given 22 by 7. This is 22 by 7. Okay. Let's use these values. 22 gets cancelled with 22. Okay. 180 upon this would be actually 9 by 5. Right. This is what you get. This becomes 9 by 5, and 9 times 5, 9 times 7 is 63 upon 5 degrees. That's what you get, right? Please observe this carefully. The 63 upon 5 degrees. Yes, 9 times 7 is 63 and this is 5. Okay. Can that be simplified further? This can be simplified as, this can be written as 12 degrees 3 by 5, right? 3 by 5 degree. What will 3 by 5 degree? This is 5 times 12 is 60, right? So you get a remainder of 3. 3 upon 5 in terms of minutes can be easily converted. 3 upon 5 times 60 minutes. 3 upon 5 degree times 60 minutes. What is that equal to? This is 36 minutes. So this is 12 degree 36 minutes in terms of degrees. That's my answer for this, right? This is 12 degree 36 minutes. That's the degree measure of that angle what they're being asked in this question. Is that all? Yes. That is all for this question over there. What does the next question say? Let's talk about this. In a circle of diameter 40 centimeter, the length of a chord is 20 centimeter. Find the length of minor arc of the chord. Okay. Let's talk about this. First, we'll have to draw the diagram. What all is given and what all is being asked. In a circle of diameter 40 centimeter. Okay. This is a circle. And the diameter, this time the diameter is given to be 40 centimeter. The length of a chord is 20 centimeter. Okay, a chord of length 20 centimeter exists. This is a chord of length 20 centimeter and the diameter is given to be 40 centimeter. Let's say this is the diameter, this is center C, this is A, this is B, and let us say this is something else, D for that matter, right? So we are given that AD, the diameter AD is equal to 40 centimeter. Okay. The radius will be half of this radius, therefore AC will be half of AD, which is 20 centimeter radius. This is my radius of the circle, right? What else? The length of a chord is 20 centimeter. AB is given to be 20 centimeter, right? Okay. By the way, we could have drawn diameter anywhere, right? And the chord also anywhere. We've just chosen a common point, just that's it. Next, what is the person saying? The person says that find the length of minor arc of the chord. Okay, this is the chord and this will be the minor arc. This will be the major arc. We are interested in this length over here. Okay, this length L equals question mark. That's the important thing. That's what we are interested in. How do we go about finding this length? Okay, if we are given the radius and we are asked to find the length, we can easily find the length if we can find the angle subtended by this arc at the center. That is this angle over here. Is the theta known to us? No, this theta is not yet known to us. But can we find this theta somehow? Let's take a look at this. So in triangle, let's observe. In triangle ABC, what do we have? We have AB is equal to 20 centimeter. Okay. AC is radius. Also BC is the radius. AC equals BC, which is the radius of circle. And what was the radius? Radius is 20 centimeter. Okay. AC, BC are radius. AB is also 20 centimeters. So that tells me that this triangle ABC is actually an equilateral triangle. Which gives me triangle ABC over here is equilateral. Triangle ABC is equilateral. Therefore, angle ACB, this angle over here is simply 60 degree. This angle, which is 60 degree, implies theta is 60 degree. We were asked to find L, not theta. But for finding L, we needed theta, so that we can apply something called L equals to R theta. L equals R times theta. This is R over here. This is the radius. What next? We have found theta, but theta is in terms of degrees. We'll have to convert this in terms of radians so we can apply that result. So, which gives me theta equals 60 degree times pi by 180. This converts in terms of radians, right? This is 60 times pi by 180 radians. Theta is equal to how many radians? From here you can note that theta is pi by 3 radians. Right. After we have found this much, we can easily solve for the length. Therefore, L equals R theta. What does that give me? L equals R. Radius is 20 centimeter. 20 times theta. Theta is pi by 3 centimeter. This is what you get. This is my answer. So this gives me L equals 20 pi by 3 centimeter. That is my answer for this question over here. It's 20 pi by 3 centimeter. That's the answer for this question over here. In a circle of diameter 40 centimeter, this is what you get. That is the length of minor arc of this circle, 20 pi by 3. You can clearly observe this, right? That's all for this question over here. Let's talk about this question. If in two circles, arcs of the same length subtend angles 60 degree and 75 degree at the center. Okay, there are two circles. The arc lengths are same. Find the ratio of the radii that is being asked, right? How do we approach this question? Let's try and draw the two circles first and then compare. There are two circles. Okay, this is one circle. This is another circle, let's say, right? This is center C1. This is center C2. Let's call them center C1 and C2. Arcs of the same length. Okay, so you have an arc length, this L. Okay, and you have same arc length over here also. This is suppose L, same length over here. This is smaller circle, longer, a bigger angle would be formed over here for obtaining the same arc length, right? This angle would be theta 1, this angle would be theta 2. Let's call this radius 1, let's call this radius 2, right? That's the diagram of the circle. L1 and L2, this arc length would have been L1, that would have been L2, but it is given that L1 equals L2. Let's mark them L1 and L2, and it is given, let's write the given condition over here. Given L1 equals L2 in that diagram, right? Two circles, arcs of the same length, subtend angles 60 degree and 75 degree at the center. Okay, so you're given 60 degree and 75 degree. Now, which do you think? If this is 60 degree, that is 75 degree. Theta 1 is equal to 60 degree. Theta 2 is equal to 75 degree. This is also given, right? Find the ratio of the radii. To find, we're supposed to find the ratio of the radii R1 upon R2. Since it's 60 degree and 75 degree, we have considered in that order. So we'll find the radii corresponding to this versus the radii corresponding to this. This ratio is being asked. R1 upon R2 is being asked, right? Once we write this clearly, properly, we are sure that we will find R1 upon R2 for this diagram over here. And let's try to do that. How do we find this? We have one simple relation. What is that? L equals R theta. Okay. So we have L1 equals L2 implies R1 theta 1 equals R2 theta 2. Since L equals R theta is something which we know. But theta 1 and theta 2 have to be in radians. Theta 1 and theta 2 have to be in radians. This theta 1 is 60 degree, which will be equal to 60 times pi by 180. This is 75 times pi upon 180. Don't forget that, right? The angles have to be in radians for applying in this formula, right? So R1 upon R2 can be easily found. R1 upon R2 is equal to what? Now R1 upon R2 would be theta 2 upon theta 1. You can observe this is theta 2 over theta 1, which gives me theta 2. What is theta 2 equal to? Theta 2 is 75 times pi upon 180. And this theta 1 is also 60 times pi upon 180. Is that simple? Yeah. So this implies that R1 upon R2 would be actually equal to this pi by 180 factor will get cancelled. 75 upon 60 is what you get, and 15 times 4, 15 times 5. 5 by 4 is what I get. This is my final answer for this question. R1 upon R2 would be equal to 5 by 4. That's the answer. Yes, that's the complete solution for this question over here. Let's solve this question over here. Find the angle in radian through which a pendulum swings if its length is 75 centimeter. Okay, and what else? Tip describes an arc of length 10 centimeter or 15 centimeter, 21 centimeter. That's the question in front of you. Now, what does a pendulum look like and what does a pendulum do? A pendulum would be a fixed rod, which is rotating about this particular point, let us say, and this is the ball at the end of the pendulum. This ball would be rotating in this manner, and this pendulum would be swinging between 2 points like this. Between these 2 points, the pendulum would be swinging tuck, tuck, in this manner, right? It will be swinging over here, and the arc that it will describe, this arc will be actually a circular arc, right? This circular arc will be part of obviously some circular path in this manner, right? And let us say the arc length is L. Let us say the arc length is L. This radius is R. Okay. And if this angle is theta, then you may observe that in the circular path, this L will be equal to R theta. For the circular path, L would be equal to R theta, where theta is in radians. Okay. The person has asked us to find the radian only, the angle in terms of radians only. And it is given that R equals 75 centimeter. R is the length of this rod, right? This length of this rod is 75 centimeter. Okay. And the tip describes an arc of length. This length is 10 centimeter or 15 centimeter or 21 centimeter. Those are the three parts. Let's talk about the first part. L equals 10 centimeter. Okay, if L is equal to 10 centimeter, that gives me, therefore, theta would be equal to L upon R, which gives me theta is L, which is 10 upon R, which is 75. This is what you get. And 5 times 2, 5 times 15. This is what you get. This is 2 upon 15. Now, what is that further equal to? This can be simplified as this is, therefore, theta is equal to 2 by 15 radian. Or it can be written as, or in terms of decimals, if you go, this is 0 point. 15 times 1 is 20. Okay, 15 times 1 is 20, 5 gets carried. 15 times 3 is 45. Then 5 gets carried, and 15 times 3, 0.133 dot. This is what you get. This is 0.13 bar radians, right? This is what you get. That's the value in terms of radians, or you can simply say 2 by 15 radians. What else? Let's talk about the second part after this. L is given to be, in the second part, L is 15 centimeter. So if L is 15 centimeter, therefore theta would be equal to what? Theta can easily be found using this result over here. Theta equals L over R. What is that equal to? L is 15 over R is 75, right? 15 over 75 is what I get. Now what does that give me? This is 1 over 5 simply, which gives me theta is equal to 0.2 radian. 1 over 5 or 0.2 radian. That's the value of theta in the second part, right? What about the third part? In case of third part, what is given is L equals 21 centimeter is given. Therefore, theta would be equal to, again, using this result over here, theta would be equal to L upon R. L is 21 centimeter. R, as you may recall, is this 75 centimeter over here. L is 21, this is 75, and this ratio would be equal to what? You can cancel by a factor of 5. You will get 7 upon 25. This is 7 upon 25 radian, or 7 upon 25 can further be simplified. Division by 25 is not a difficult thing. You can always do that. Multiply this numerator by 4 and put a decimal after 2 places from the right. This is 0.28 radian. That's my answer for this. Third part over here. This is the final solution for this complete question, as you can see behind me. Right? That is all in this question. And with this, we have reached the conclusion of this exercise 3.1 based on trigonometric functions of NCERT class 11th. In the next session, we'll be talking about another exercise. Till then, all the best.